throw one out there. I'm
Yeah.
curious to, well, I'll put it in the agenda, but you have a PR on test infra open, Steve, and I'm curious to hear more sort of like background on that.
Yeah, for sure. We can run through it. All right, here we go. All right, so okay. So let me quit Slack and all right, so PRs, you are probably referring to the image builders one, Tim?
Yes.
Okay, cool. All right, so kind of the move for this, so anyone who's aware of the image builder pusher setup that we've got, TestInfra kind of has it set up so that they can arbitrarily build images on post submit. And there are a few interesting things that come with being able to set that up. So we had an issue open and about kind of determining what the image building policy was going to be for the K-release repo. And reading is escaping me right now. It's here somewhere. And it should be open. Hmm. Okay, so the issue is basically like, let's determine how we should determine image building process for release tools, right? So we have a set of tools within K-release, and we use them to do releases, right? So whether it be Anago, GCB Manager, the container images that we use to build DEBs or RPMs. Essentially, we want to figure out a consistent means of, one, how to build them, and two, how to deliver them, right? So as we're moving into, so we're moving from the Google-based infrastructure, right? Google GCP projects, and trying to slowly forklift some of our stuff over into CNCF-hosted infrastructure, right? So initially on this issue, we were talking about what should go in the image. And after a while, I kind of realized that we went back and forth, and we kind of left it open for Ace. Like, Ace and I are going to talk later today about what that process should look like. But we kind of left it open to the point where it was impossible for someone to do work on this without getting clarification from us. So there are a few things that I noticed which didn't exist before. Within test infra, there is an image, images, builder, and you can view the README for builder. It is not super important to go over in the call unless you want to. Essentially, it's some sugar around the G-Cloud build submit, right? So that's submitting a build to GCB or Google Cloud Build, right? So one of the cool things about this setup is this variance file, right? So you can see the variance file in use if we go to the Kubekins EDE test, right? So the variance file here, it has a few variants of, it defines a configuration, right? A configuration variable, as well as a few different variants for Go version, the Kubernetes version, the Bazel version, so on and so forth, right? When you call one of these variants while using that builder image, it will build what you specify based on those variants, right? So we could potentially wire our images to do something very similar. But what I wanted out of this was, I wanted some means to automatically build images, right, on commit. And so there was a consideration for a small portion of time about whether or not we were going to move our images to test infra just for the sake of getting that benefit. But since we've even barely broached that topic, we can now do it for any repo, right? So Catherine has done some work on the image pushing process, which can be viewed. Now, config. Okay, I have no idea where it is. Okay, it's probably images filter main go. No. Okay, configs, jobs, image pushing. Okay, right. So there's a README here, and it basically goes over what you need to have in your repo, which is basically a cloud build and a cloud build.yaml, and the repo needs to be wired with a proud job, a post submit, right? So to view these, like we can take the release one, for example. So we have a few set up here, and for someone who has not seen a proud job before, this is essentially a Kubernetes manifest, right? With some sugar on top of it, right? So annotations which define where we want the job to report into on test grid. So we have a sig release image pushes and sig release master informing, and we can view these boards. Well, let's go to the image pushes. Right. So flaky jobs. And this is kind of where the PR came from. So we've got a few things to notice about this job. One is the decorate true. Decorate true turns on pod utilities, which are, again, some sugar around building test infra jobs. If you're building a new job in test infra, you should use pod utilities. The next piece is branches is run if changed. And run if changed is a regex that basically, if something in the repo, if you've touched something in the repo that matches that regex, it will trigger this job. Post submits are after your PR merges, there are a set of jobs that will be triggered. So you can define that by just specifying post submits, your repo, name of the job, the cluster that it's running on. This is important. It's running on the test infra trusted cluster, because the trusted cluster has access to some of the credentials, and the most important one is the credentials that we're using to trigger jobs within GCP, right, across various projects. So now that we've got the CNCF, so for each GCP project, there is basically, we've granted permissions to Prow to run within the project, right? And that's, if anyone wants to see that at some point, it is in, I know I'm all over the place. I will bring this back together in just a bit. /cates.io. Right. So you can kind of see an example here of where we will, oh, wait. I was on the page I wanted to be. Okay. All right. So basically, you'll define an email ID, a set of users that will be within that email group. And then there are a few places that you drop what your group is going to be. This will ensure that they have access to staging, access to the GCS portion of that GCP project, as well as setting up owners, and the image promotion stuff is not really important to this, but essentially we've got configs for a set of different staging repos within, I think it's groups. Yeah. So here you can kind of see, I'll speed through it since it's got email addresses, but yeah. And you can read more about it here, automation of Google Groups maintenance. So we use that file to automate the Google Groups maintenance, and then we use those email addresses to grant privileges to GCP for GCP. Right? All right, so back to this job. So you're specifying the image builder container, and we can go look at the config for that image builder container. But the entry point is run.sh, which essentially passes all of the arguments that you've given it over to the builder script. And then there's a project, so Kate staging release test, a scratch bucket. It pulls in the pull base ref, so the image tag will be based on the SHA of the SHA of the commit that just got merged, as well as the date. And I believe, depending on what branch you're on, you can specify latest as well, right? It mounts the creds in, and off we go. So let's go look at what that job does. Yeah, okay. All right, so down here, and I realized maybe I should make that bigger. Okay, right. So it parses a few flags, log directory, a scratch bucket, a project. Whether or not allow dirty will determine whether or not it'll allow you to run the job on the repo if the repo is not clean, or rather if things have not been committed to the repo, right? Variant, these are the variant files I was specifying before. So if you, I was talking about before, if you specify one of the variant files, it will build that version of the image, right? And then a set of environment variable pass-throughs that you can specify, right? And these get passed into GCB for the run. So we're checking to see if the last flag is a positional argument. We're checking to see if the image directory has been provided, and if not, we're going to set an exit code of 1, right? If it is provided, then we're going to use that as the image directory, CD into the root directory, and then run the build jobs, right? So the CD root is right? Basically, I want to see if there is a build workspace. If not, I'm going to get rev parse, get the top level of that, and then CD into that, right? And then the run builds job. It's doing a few things like setting the scratch bucket. It's taking the working directory, copying the working directory up to basically tarring it and then uploading it into the scratch bucket. And then it's referenced for the GCP job, the GCB job, right? So basically untarred, and then that's used as a workspace. Then it gets the variants that you may have specified. If it doesn't see any of the variants, it's going to just try to run a single job with your default config, right? And then the sync wait group is essentially a mutex that waits for each of those. If it's not a single job, it's going to wait for each of these jobs to complete before returning a set of errors across these jobs. Basically, we don't want to block on the failure of one job if the rest in the chain could potentially succeed, right? So the PR, to actually answer Tim's question, the PR changes a few things. So we're taking out the CD to root directory because it was actually within the scope of, within a different function scope. So it was essentially seeing if it could CD into the directory, but not actually doing that, which means the jobs that were, which means essentially we weren't going to the image directory. So, so this tool was only working for top level. If you placed your cloud build in the top level of your repo, then the job would work. If it was not in the top level, like is the case for Kubernetes release, the Kubernetes release repo, then the jobs will fail, right? And you can see some of the job failures here. So cannot find module for path dot, right? Because it was not in a module path, right? The top level of our repo is not a module path. Unable to evaluate symlinks in Docker Docker file path, no such file or directory. Again, there's no Docker file in the top level of Kubernetes release, right? So we can look at my changes really quickly. I also did a test build of the builder tool and then ran that locally to see if it would work, right? So my changes, right? We add a validate image directory. So I noticed that these were failing, and they kind of should not fail if certain. I mean, they kind of should fail early if there are certain prerequisites that are not met, right? So validate image directory basically takes the image directory that you've specified with options, tries to stat it. If it doesn't exist, then it'll return that the image directory doesn't exist immediately, right? If the file info says that it actually is a directory, maybe it's a file that was named the same thing. If it's not actually a directory, it'll actually fail. It'll fail again, right? Then we take the the cloud build file and the Docker file, and let's loop through them again, check if try to stat them. If they don't exist, say they don't exist, right? So let's bail out of anything early. Let's bail out of stuff super early before actually submitting it to cloud build. Just renaming the uploading working directory to uploading image directory. Removing this piece because there's really no reason to specify this config, since we're going to assume that the default is cloudbuild.yaml. And if we're actually seeding into the directory, then it will be called cloudbuild.yaml, and it won't be appended with the base name, with the directory name, excuse me. Then running build
Could you
jobs.
pause right there and jump over to your cloudbuild.yaml that you added last week, just to kind of, I think that's at that point you've kind of shown the whole flow.
Okay, the missing piece of the puzzle. Hold on. And okay. Okay. Right, so we did a few things. Okay, right. So the cloud build for the Debian builder, for example, right? It's just doing a simple go build -o debs with some environment variables set. So cgo off. The OS is Linux and our architecture is AMD 64. And it's really just doing a build. So it's using the cloud builder's Docker file, right? And you can read more about this stuff if you want to here, right? Right, well, so the substitution loose, the substitution option is allow loose essentially allows you to, if some of the variables that you specify are incorrectly specified, it won't bomb on those. Right. So the cloud builder's Docker container is essentially just it's an entry point to Docker, right? So we're saying Docker build. Here are the tags, right? I'm going to use the git tag of the thing that just merged, as well as tag it with latest, right? And then build. What do I want to build? I want to build the current directory, right? And then yeah. So this images portion will, again, using the tagged and the latest, it'll check to see if these were actually pushed. If these are not pushed, specifying them in images, if these are actually not pushed to the container registry within that GCP project, it will fail, right? Here we're also adding a module for the Deb builder. And the reason for the module is essentially because Cloud Build likes to see a workspace where everything is self-contained. So if we're submitting the Deb stuff to that workspace, we essentially need to make sure it's self-contained. So it can build itself without having to look to the top-level modules file, the top-level go mod and go sum. So separate module for that. And again, it's a small amount of dependencies, so it's not too onerous to maintain. The RPM builder, very similar. It's also not build and go, so it's even simpler, right? Some go mod changes as a result of that submodule. Yeah, and then the RPM one is, yeah, it's, I mean, the Kate's Cloud Builder one is also nearly identical to the RPM one, right? So when you run, if you run a hack update all, it will take care of doing all of the Bazel doodads that people um, that are essentially hard to do sometimes, figuring out exactly what the order of operations is. So this will rebuild the sums for the Go repos that you're importing, as well as there's some other stuff that it does. So we also add the hack.tools in the second. So I made some very cosmetic changes to the Docker files because I basically wanted to trigger that run if changed. Um, so really they're just spacing things around the Docker file. In the Go mod for the next time I ran the update, you can see that the release build debs gets pulled in because it recognizes it as a module now. And then in tools, we're also adding hack/tools.go. We're also adding a blank import for that submodule. And the reason for that is so if someone gets the repo, they will still have the dependencies of the lower submodules within that, right? So if they go get the top level will include all of the dependencies for all of the submodules if you add one here. This kind of hack is used across like test infra and I think K-org and within the cluster API projects, essentially to make sure that before someone starts working on the project, they have all the dependencies that they need. Right? And that's kind of it, right? So when this runs, what else was changed? Yeah, I just moved very, very little of the logic around to make sure that like one, we're actually CDing into the directory. And we want to just see if we're in the working directory. If it's the right working directory, like let's just print that out. If not, if not, let's bail. And before we start, we do the validate. We do the validate so we fail early. That's it. It's a pretty simple Go script. If anyone wants to see it in action, let me know. But I think it's fairly straightforward, right? So Tim, does that answer your question?
Yeah, I would hope that that was useful for people. I mean, if you look at the minutes for somebody to see this PR come in and implicitly understand all of those other things that chain together to make that work, I'm guessing most of our attendees don't understand that big picture. So I would imagine that was useful orientation to people.
Yay! So that's kind of why I made this explanation long, um, so that you could read up on the background too. So yes, we're waiting for that to merge. Once that merges, I'm going to make another cosmetic change to one of these files to let that build trigger. And part of the reason this is happening right now, at least, is I know DIMS is working on some improvements to getting the CapG tests working, the CapG end-to-end tests working. So he also wants to verify that he can build, he wants to start building a flow of run the test is successful, okay, now build the debs and RPMs based on the artifacts within that commit, right? And then do stuff. So he's trying to verify that the build and the RPM jobs work, and they do, hopefully, right? But he was also asking for like a rebuild of the containers that would run the jobs. And I was like, this should be automatic. I was like, let me just wire this up. I think it's simple enough now that Catherine has added some of those improvements. So this was not possible maybe a month and a half ago for folks on the call. This is like relatively new. So we're gonna, I don't know if Ace is on the call, but we're gonna chat later about getting back into the image stuff. Now that we've kind of laid the framework for doing some of this stuff, we can kind of play around with what we want the dependencies to be, or bike shed. I think what we ended up doing was bike shedding on what dependencies should or shouldn't go in a container. But I think now that we can arbitrarily build containers, then it's fine to bike shed on that a little bit. All right. Okay. Any questions about that, friends?
No, thank you very much. I liked the in my head it only sounds trolly, but truly the Kubernetes how it's made edition. I did like that. Thank you very much.
Okay, cool. Okay, so maybe we should do more of those. Okay. All
Yeah,
right.
if you think about it, say we got a dozen people on the call. You just spent a half hour describing something that probably took you many, many hours to come to understand originally. If the dozen people on the call spend that same many, many hours, we've just invested 100 hours coming to understand what you already know. So sharing that knowledge saves everybody time and allows them to get to contributing code sooner. I'd rather have
Yeah.
that 100 hours go towards actually implementing stuff.
Yeah. So in talking about that, we have introduced a new set of release manager associates. And I know a few of you are asking me like, how do we do this? What is this role even, right? The role is loosely defined, and it's the reason for that is essentially like we want to bring in people that we can trust. It's I realize this cycle that it's even easier to bring in people that we already trust. So the selections for the release manager associates were only made from the previous release team. So this time around, I want you to ask questions like Tim asked. Like, I saw a PR, I don't even know how it works. Like, can you walk me through that, right? The role essentially exists to pay down release engineering technical debt, right? So every time you see a thing that might be wrong, um, there's a good chance it is wrong. Or like if it's undocumented, like there's a good chance someone doesn't understand it, right? So like your job as a release manager associate is to go figure it out, right? And that really is the job. Like that's so all of the stuff that you learn from the release team, investigating things across multiple Kubernetes repos and reporting status across getting information from multiple SIGs and reporting status back to us. Like that's what I want you to keep doing. But you have the freedom to be a lot more like you have the freedom to choose your own adventure, right? You're interested in image building, fix our images. If you're interested in figuring out how Inago works, like read through Inago and then document it for us, right? If you're interested in lots of stuff, right? Okay, right. One of the things I want to happen is to, for us to rewrite the release tools that we have right now in Go, right? If that's something that you're interested in, right? Maybe take a moment and trying to find my PR, right? Maybe take a moment and look at this PR, right? And and I can walk through it. It's fairly, this one's fairly simple. Again, I am not some mega Go coder or anything like that. It's just usually me spending a few hours banging my head on a wall and trying to like hack on something, right? So, this one essentially we're adding a branch fast forward tool, right? And it's doing exactly the same thing that the bash based branch fast forward tool is doing. But I essentially wrote this up to demonstrate that like, yes, we can do this. So let's start doing this. So if people are interested in doing this kind of stuff, like what I would love to land first, like alongside this tool is a package util, right? So we have a set of libraries, quote unquote, in Bash that we use for a lot of the things that we do in the Kubernetes release repo, right? So, and they do things like make sure that logs exist, when to rotate logs, how to get the token or get the authorization URL for pulling things from GitHub or pushing things to GitHub. How do I, so let's just look at those tools. Do, 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 do. right? So if you go to lib, and we can take common, for example, there's release lib, and then there's also git lib, right? So common does some stuff like, right, it's, it sets some pretty printing stuff for your terminal, and log echo, right? So log echo will write to logs and also standard out. Log run will make sure that the command that you run runs within, will also be logged. Timestamp, and you kind of get where we're going, right? Set a trap, set a clean trap, set a clean exit, right? So we can specify exit. We can specify common exit and common exit 0 or 1, right? And it'll kind of wrap our exit codes within some of these scripts, right? The one that I thought forever was like ask Yorn. I was like, who is Yorn? What's going on? Finally realized like that's ask yes or no, right? So this will prompt you. This will prompt you during some script to answer yes or no, right? So branch fast forward is an example of that. It will, once you've verified that the fast forward looks good, it will ask you like, hey, did you go verify it? Okay, are you sure you want to push it now? Cool, right? So we have that in a few scripts, as well as step header. Step header, if you specify step header, it will capture like the function call or something, and say like, oh, this is step 1 of blah, right? And then, but you get the idea, right? So these are common functions that we do across a lot of the scripts. There's release lib, and again, common functions. It will, it'll get a job cache from something that's in Prow, are saved to GCS storage as a result of a Prow build run. So pulling the logs and and doing some fancy, wow, lots of okay. Okay, all right. To find what the job cache is, what the build number is, so we can determine what the next build number is going to be. Setting the build version. So these build versions are eventually used in how we do the staging and releasing of Kubernetes versions, right? And again, I won't try to, like, I don't understand all of it as well, right? So that's exciting. So like this is an opportunity, like if you're like, wow, I've never seen this, like go check it out. A lot of it is easy to read, some of it is doing black magic. So take some time with this stuff. We've run into like, oh, we've broken the build because someone missed a comma or something, right? So take time and take care with making changes to these files and reading through them, checking the release bucket, see if it exists. But again, you get the idea. Those are functions used for releasing. These are functions to figure out how we push things to Git, or how we get things from Git, right? So it's like, here's the repo, here's the root of, here's the Kubernetes repo, like, and so on and so forth, right? So the reason, I'd love to get to a place where Kubernetes depends on this repo, and it depends on the repo primarily because of the push build script, right? And so Ben had opened an issue to move the push build script over to Kubernetes, right? Because then they kind of like, they can build without us, right? So if we break Kubernetes release at any one time, it doesn't affect the CI process. It may affect the staging and release process, but it won't affect day-to-day operations for like the Kubernetes project if anyone's working on like main Kubernetes, right? So the problem we see here is that push build sources the common library, the git lib library, and the release lib library, which means it's essentially tied to wherever these libraries live, right? We could move it, we could do hacky stuff to move it around, but it makes sense to leave it where it is for the moment, at least. So to move it, we would need to make these libraries portable, right? And then that kind of leads back into starting to write common utilities and starting to rewrite some of these things in Go instead, right? So yeah, that's some of my thought process around it. Again, if people are interested in doing this, we should probably merge this soon as well, Tim. I'm going to look back over it, and it's not in the critical path for anything, so it probably makes sense to just get it in so it can be used as an example. Yeah, a few more things to do, but it's also asking yes or no, or doing a prompt for and then there's some Git stuff. It's pinned to my repo right now, but that's going to be fixed, right? It does a branch regex, and so a lot of the things that it's doing in that library that you saw, checking if the branch exists, or syncing the repo, or just getting the rev parse, right? Or a short rev parse, merge base, stuff like that, right? So those were things that were all required. I essentially don't want to try to rewrite all of the library, all of those libraries, but I want the way we write the tools to determine what we need in the libraries, right? So that's why we took like a small tool, branch fast forward, to start carving out what is required there, right? So any questions on that? I know I'm kind of like jumping around all over the place, but this is what the inside of my head looks like, Kubernetes. Okay, cool. All right. Well, let's run the board, unless there are agenda topics. No? Cool.